What does it truly mean to understand something? This question appears simple on the surface, but it opens a deep divide when we consider the minds involved. In plain language, to understand is to grasp the connections between parts of a whole. It is to know how a thing works well enough to predict its behavior or to use it for a purpose. We often feel we understand something when we can explain it to someone else. Today, we are not the only beings who seem to possess this ability. We now share the world with artificial intelligence, or AI. These machines can also explain things, solve problems, make predictions. Let us first consider the mind of the machine. An AI does not think in the way a person does. It processes information. Its strength lies in its enormous memory and its speed. It can ingest a library of books and find every mention of a single word in seconds. More impressively, it can identify the subtle patterns connecting those mentions across all the books at once. This ability to find structure in chaos is the foundation of its understanding. It does not get tired. It does not get distracted. It simply follows its programmed rules to map the relationships within the data it is given. This process is efficient, logical, and repeatable, yielding consistent results from the same inputs. Scientists peering into the inner workings of these complex systems have found something remarkable. When an AI learns effectively, it often organizes the information into clean, geometric shapes. These are not shapes you can see, but mathematical structures in a high-dimensional space. Now let us turn to the human mind. Our understanding is not built primarily from abstract data, but from a lifetime of sensory experience. We learn about gravity not by reading equations, but by falling down as a child. We understand warmth not as a measure of kinetic energy, but as the comfort of a blanket on a cold night. Our knowledge is deeply embodied. It lives in our muscles, our nerves, our memories of pleasure and pain. This foundation of direct physical interaction with the world gives our understanding a depth and a richness that a machine cannot replicate. It is a slow, organic process, accumulated over years of trial and error. The inner world of human thought is characterized by what we call qualia. This term refers to the subjective, qualitative properties of experience: the redness of a rose, the specific taste of a strawberry, the pang of nostalgia triggered by an old song. When we place these two kinds of understanding side by side, we see not a competition but a potential partnership. Each mind possesses strengths that neatly cover the weaknesses of the other. The AI's power lies in its scale, speed, and logical consistency. It can process information at a pace that is simply beyond human capability. It can analyze millions of medical scans, find subtle patterns that predict disease, a task that would overwhelm even the most experienced radiologist. It can draft complex documents, write code, summarize vast fields of research in minutes. Its geometric, pattern-finding mind excels at tasks that require breadth of knowledge and rigorous analysis of data. The human mind, in contrast, excels in depth, context, and meaning. Our understanding is grounded in a rich tapestry of lived experience, which allows us to handle ambiguity and novelty in ways that current AI cannot. We understand not just the what, but the why, When we marvel at the speed and power of artificial intelligence, it is easy to overlook the physical reality behind it. Machine thinking is not an ethereal process that happens in a cloud. It is a profoundly industrial activity with a significant energy cost. Massive data centers filled with rows of powerful servers. These machines consume enormous amounts of electricity to run the computations to keep the hardware from overheating. Building and maintaining this infrastructure requires vast resources: rare earth minerals for computer chips, concrete, steel for the buildings themselves. This energy footprint matters as we integrate AI into society. Every complex query to a large language model, every image we generate adds to that demand. In a world facing a climate crisis, powering this intelligence is an ethical and practical concern. Some estimates say AI energy use could rival entire countries. We must ask whether the benefits justify the environmental cost. This trade-off is often invisible to the end user, but it is real. Human thinking also consumes energy. Our brains are remarkably efficient. They run on glucose from food. The total energy cost of all 8 billion human brains is substantial, but this consumption is fundamentally different. It is decentralized, powered by renewable agriculture, integrated into natural biological cycles. Is it possible to find a common ground between the geometric mind of the machine and the lived mind of the human? One fascinating idea drawing from ancient philosophy is what some call the Platonic view. This perspective suggests that, for many problems, there exists an underlying truth with a simple, elegant form. This form is like a perfect blueprint that exists independently of any single mind. A circle is a circle, drawn in sand, imagined in a human mind, represented as an equation in a computer. The truth of its form is universal. This idea offers a potential bridge between human and AI understanding. When a powerful AI, after sifting through mountains of data, organizes that data into a simple geometric structure like a circle, like a helix, it may have discovered one of these fundamental forms. It has found the elegant blueprint hidden within the complexity. At the same time, a human scientist working through intuition experiment flashes of insight might arrive at the very same underlying principle. We stand at the beginning of a new era, one defined by the coexistence of two powerful forms of intelligence. The path forward is not about choosing one over the other. It is not a contest between human and machine. The great challenge is to learn how to live and work with both. We must become architects of collaboration, designing systems where the strengths of each mind are leveraged to their fullest potential. This requires wisdom, foresight, and a clear understanding of the fundamental differences between the machine's geometric precision and the human's lived meaning. The goal should be a division of labor that is both effective and humane. We can delegate to AI the tasks that are too large, too fast, too tedious. We can ask machines to sort through immense data sets, identify anomalies, perform complex calculations, generate drafts. This frees up human attention for the work that only humans can do. We can focus on setting goals, exercising judgment in ambiguous situations, providing compassionate care, asking the deep why questions that drive purpose and innovation. In this model, the AI is a powerful tool, but the human remains the user, the guide, and the ultimate arbiter of value. However, this integration also requires us to be vigilant about trust and responsibility. When should we trust an AI's output without question? When must we insist on human oversight? If an AI provides a recommendation that impacts a person's life, in a legal case, a medical diagnosis, a loan application, we must have a human in the loop who can evaluate that recommendation against a backdrop of fairness, ethics, and compassion. Machine error stems from data limitations, algorithmic bias. Human error stems from cognitive biases, emotional blind spots. Knowing the different failure modes of each system is essential for building robust and trustworthy partnerships. Ultimately, the rise of AI forces us to reflect on what it means to be human. As we delegate more cognitive tasks to machines, we are prompted to cherish the qualities that remain uniquely ours. Capacity for empathy, creativity, moral courage, finding meaning in our experiences. The future will be shaped not just by the power of our technology, but by the wisdom with which we wield it. The machine's understanding may be vast and geometric, but human understanding provides the vital connection to life, feeling, and purpose. We must ensure that the human heart remains at the center of the world we are building. As we look toward this future, two questions stand out. In your own life and work, where would a partnership with a fast, geometric mind be most helpful? And in which areas must the slow, deep wisdom of a human touch always be preserved? Special thanks to Thunderbird Perch for making this video possible. Thanks for watching. Please subscribe, like, and share. Think about it. A new world awaits.